Okay, we'll do it again.
Unless you want to stand all the time.
I like when cheese and jerky.
Making fire float on air. Be a little impressed, right? Okay. So before I turn on lights, if you guys really watch, the really cool thing is that you can see that molecules don't exist. So right now, alcohol molecules are riding on top of something, and they're interacting with the oxygen coming in through the opening, and you can actually see where that's occurring. So it's a fun way of being able to actually see molecules moving. Okay, lights on. So if you now look at this, it's super, super foggy, okay? So if I take one that now hasn't been used, you can see that there is a difference between the two, because this one had a combustion reaction in it. The combustion reaction, one of the products is carbon dioxide. What happens to fire and carbon dioxide? Does fire like carbon dioxide, yes or no? It does not, okay? Or else fire extinguishers would be kind of pointless. So we're able to keep the fire out. And then the other one is water. So water is also something in here. Does fire like water? No. So that keeps everything out. So here we have a bottle that is now saturated with carbon dioxide and water. And the water actually acts like a candle. And in between it, alcohol molecules are traveling between the water, coming to this opening where it reacts with the oxygen and is able to have a fire sustain. You can see that well, it's kind of the undulation of the flame. The other thing is, the stuff I'm putting in here is just alcohol. So, as one of the things that we'll go over throughout today is that it's not the actual liquid here that's flammable, it's the vapor. So I don't want to just put tons and tons of stuff. I want to have just enough inside of here so that when I spin it around and things like that, I'm able to maximize how much alcohol vapor is actually inside. So by moving it around, I'm spreading all of the alcohol so that I can get 100% of the air saturated with alcohol inside of this. So I'll do a cool thing.
That was you, motherfucker.
When you say that, you say
I was not.
okay.
I wasn't.
I do need to talk.
You bitch. That was you. That was him. You're side-eyeing this man, so you know it's him.
It's not him. But it's the purge.
You guys are just gonna get hit. sight is not as that. Okay, so never tried this at home. This one actually is super, super dangerous. And a teacher in Adams City actually got fired for this one. So don't ever try this at home. Thanks. Come on.
Stomach.
Sometimes it takes a bit.
Yeah, let's not play that way.
Once it works, it works. Do you need light?
No. Okay, I gotta grab you. Okay, ladies. Burn, burn. Okay, like. Bring me the bottle. Thank you.
Good job, baby. Good boy. Yeah, you're the one with
So, I end up becoming a chemist because I always kind of like the idea of pharmaceuticals, stuff like that. I didn't want to be a doctor, but kind of wanted to be able to play with drugs, and then I became a teacher. But not a PhD. Eating. So the one of the things that I get to do during Halloween, since you all give your souls in the green fire today, is we're gonna help this little buddy. He's sick of a pumpkin. I mean, he's not feeling very well. Okay, so we're going to help him by putting in some mixture, and we are going to use the old way of being able to cure people, which is induce vomiting. Try to make his vomit green, for science. So if you guys want to touch his vomit, you can touch vomit, touch vomit, touch it.
David, go touch it. Here, David. You're right by you, David. David,
Come on, touch vomit.
lick the vomit. Good boy. Let's go Steelers. Someone draw Scorpion from Mortal Kombat. That's crazy.
So I'm going to do this again, but this time you can actually more so see the what was going on. So this is elephant toothpaste. So what I use is hydrogen peroxide. So it's 10 times more concentrated than the hydrogen peroxide that you can buy at a store. And then I'm using potassium iodide to be able to liberate all of the oxygen as much as possible. Hi, Miranda.
No, don't stand by the door. That's dangerous. Okay, so. This is what I do to lights.
Don't ask questions. I'm a curious guy. I'm curious, bro. Just get secure. Bro, my sister killing her boyfriend. She's Georgie and she's pale. Oh, la verga.
Alright. See if I can stay in the room again.
Let me do some shit. Caesar, go touch it.
If you guys want to come touch this one, it's even better. It's really hot. You can see how much steam is coming off of it. It won't break it. So.
Alvin, go touch it.
And you can also be a hazard of falling on you. Come on, don't be late. Come on, interact, guys. The whole point of this is the
It is, it's just soap. Elephant's toothpaste.
fire. Gonna have a little ghost pumpkin using some science. So get him spinning, and he can just sit here and watch you all. So we're gonna add things to get him going. So it will end up changing this color and then be colorless. And it'll just keep cycling through that, being able to watch all. And here I have another little pumpkin that we can change colors back and forth. But this one we can watch going from adolescence to then becoming a jack-o'-lantern. And while those two are, kind of doing their thing, we'll set up another little experiment here where one of the things that always happens in, like movies and shows and stuff like that, they're always like, if I mix these things together, am I going to start a fire or blow something up? It's actually really hard to do in chemistry. Most things are not flammable. Most things are not explodable. So it's actually a very difficult thing and a rare thing to actually do. You would cause a fire or an explosion, but this one is one of the rare occasions where by mixing these things together, you can get that. So I have this kind of oily substance. I'm going to put these purple crystals on here. And it'll take a second. Watch what happens. That was an exothermic reaction. So the things that are mixed together is glycerin. It's a carbon oily substance with calcium permanganate, which is a very strong oxidizer. So by mixing strong oxidizer with a carbon-containing compound, it was actually able to start a reaction which basically turned all the glycerin into charcoal. So that's pretty much, I just have like a little mixture of charcoal here. And get this little guy to go bleed again. I've been talking a lot, man. I need to hydrate. Hey, see, now he's a ghost again. That one's kind of changing back a little bit. Oh, look, he's going. Ah, that one's going too. While we watch this, the water's just not doing it for me, so I'm gonna take some Kool-Aid really quick. Oh, we should make him green again, right? While I'm staying hydrated here. But you know, if I'm really wanting to stay hydrated, I need something instead of Kool-Aid. I probably should just be drinking water. So. Delicious. So, what you're seeing right here, this is an acid-base reaction. And it uses an acid-base indicator called phenolphthalein. So phenolphthalein is pink when it's acidic, or when it's basic, and colorless when there's acid. So right now I have an acid in here. The acid that I'm using is vinegar. So it tastes like vinegar. The base this year, I decided to be a little bit different. So that I got really tired of always drinking floor cleaner. So I decided to change it up this year and drink drain cleaner instead. Go into trash. Go into trash. So, while these guys are also going back and forth, you see my stack of cups, yes. Much taller than my little cauldron here. So, I'm going to make these cups fit into the cauldron. Anybody have any money? I'd love large bill. Anybody have like 50, 100? Somebody has to have cash. What do you got?
$1 million.
20? Anybody have anything better than a 20? I'd love, 50 or 100. I got 2 50s yesterday and a 20. I'd love some bigger bills. We got seniors.
This is where we can get food stamps.
No, I want bigger bills. $10 bill? No. Singles broke. Yeah, we're gonna gonna steal from a teacher? Nobody else has any cash? Nobody?
I have a literal $1 million.
This thing was $20. That's all I got. Sucks to be you. I'm gonna be your bully then. Okay, so watching it, yes. Okay, ready? Keep your eyes on it, keep your eyes on it. Hey, wait a second. Okay, like Hey, wait a second. Okay, like, so if you look, other than now Mr. Single's money's just, really, really wet, and now mine, that it's completely fine, okay? Which, again, shows you that it's not the liquid as the thing that's burning, it's the vapor coming off of it. And because we have the vapor coming off of it, we can do something else then. You were just on fire! Okay, my hand. Yep, try the other hand. Yeah. Maybe the other hand is more burnable. I was having a problem with it being burnable yesterday too. Oh, there we go. There we go. So, one of the things that you'll be able to do is light your hand on fire, okay, so that's one of the things that you'll be able to do, which I'll light your hand on fire over here. Over on this wall, I have a spirit wall, and there's paintbrushes and solution inside of those flasks. You can write on the paper, and your messages will then be absorbed by the spirits, okay? The only thing I ask, please don't write anything inappropriate. So far, everybody's been really good. I have seen 0 penises, so woo! That is great. Okay, it's a good day. So that is one of the things, and then the third thing is over here. So a couple safety things, because there's a bunch of us. Just make sure that you're not rushing. There's plenty of time. You'll be able to do everything. So lighting hand on fire over there, spirit wall, and then over here with the bubbles. Couple things. What direction does fire go? Up, okay. So when you are coming over here with Miss Basil, you want to make sure that your hand is out, nice and long, and about eye level, so that the fireball goes up and around your head, not towards your head. I don't want to burn off your eyebrows or your hair, okay? So you will want to make sure you're out. The other thing is make sure your fingers are nice and closed tight together. This stops so that you don't get any burns in between your fingers. Okay, so nice and tight, close together, and out, okay? And then Miss Basil's going to hold your wrist, because for some reason, everybody, when this happens, it's fire, it's going to be hot. This isn't fake fire, it's real fire, okay? Is that you're here, and then all of a sudden it's like, fireball, ah! Okay? And you pull your arm down. Again, what direction does fire go? Up. That means if you pull your arm down, fire goes up your body. Goodbye eyebrows, goodbye hair. Okay? We don't want that to happen. You want to make sure that you are holding and standing still. It lasts at most 2 seconds. You will survive. You will not get burned severely. And you'll be okay. All right? So you just stand there. And then the other reason why Miss Basil holds so that you don't come down is also that people want to wiggle. Don't wiggle. Okay? You wiggle, now you're throwing fire at Miss Basil, lighting her on fire. She's definitely not going to appreciate that. So don't wiggle. Okay? So she will hold your arm nice and tight. So you'll come over here underneath this vent, facing this direction. Make sure you guys grab goggles, because you can take photos, things like that. Put them on your social media. It's awesome. No. So you put on goggles so that if they do go on social media, so all of a sudden like, why are you guys not being safe? Okay, so goggles, you'll come over here, you're going to grab some bubbles, okay, get a good amount of them, and then you just hold still, and Miss Basil will light you. See? I'm completely fine. Okay? I'll have all the sinks running so you can rinse your hands. So don't turn the sinks off, just leave them running so that avoids splattering. And yeah, so go ahead, line up, and I'll turn on the sinks. Dip your hands, right shot.
Tuck your thumb in. Ready? Good job. Right now, you can. Ready? Don't move. It's warm, isn't it?
That made me jump. It's like one of those rides from Universal Studios.
So, this is the stuff that I was breathing through the tube. So, I'm going to put a pile of it right here. It is very flammable. You guys all saw it was super flammable. Okay? Safety first. See the big one? So, this is an important lesson of, again, just because you have lots of amounts of stuff doesn't mean you're going to get anything cool. So I have a large pile of the very flammable stuff, but it's all about air to fuel ratio. So there's too much fuel to air currently inside of this pile right here. So I can change that, see if I can get it to work, by doing this. Ah! Hold on, let me relight on. So, by changing the air-fuel ratio, you can get much cooler things to happen. So it's always not just about more of stuff to ever get a really cool reaction or something on fire. It's all about your ratios. All right. So, this next one, you guys are, once it starts going, I'm going to need you guys to come up and you're going to need to smell this, okay? So, I have a magic bottle here. We're going to make a genie come out, but I want you guys to smell the genie, okay? So, you guys are going to have to come up here and smell this. Yeah. Come up, smell it. Smell it. Smell it.
And it feels like
So, that is the smell of oxygen. Okay, so we are used to about 19% oxygen. we don't actually smell it. We have no effect at all about how much oxygen, but there was 100% oxygen that you breathed in, and it's actually toxic to us when it's at that level. So that's part of the early association. So oxygen can even be bad for you. So this next one, I'm going to have a little assistant here, okay? My little friend. And my little friend here needs to become possessed. Okay? So to help her get possessed, we are going to use some magic crystals, and we're going to be able to measure how we can tell that she is getting possessed. So, this is super scientific technique right here. Bang things on the table. So, I'm going to take some of these crystals. Ooh, that was way too much. Then I'm going to mix these together. So how could we tell that there's a spirit around? What happens to the temperature? It's really, really cold. So if we end up getting her possessed, we'll be able to tell because she'll start to get really, really cold. So it's starting to actually turn into a paste now. So my crystals are becoming paste, and now they're going to start turning into a liquid really quickly. There it goes. So now it's becoming a liquid, and you can feel how cold she is. Super cold.
Smells like ammonia almost.
It's just like
So that is one of the few easy reactions that's really, really cold. So while I'm setting up this next one, I'm going to need your help. You guys have to, okay? So you have to think about this reaction. or else it doesn't. Think. So, you guys have to think about it. Think about it. You guys aren't thinking hard enough about that one.
Oh, what the fuck? It turned black.
His clothes?
No, the liquid, yeah, the.
So, I'll do it one more time, but again, you guys got to think about it.
That's exactly what happened.
You'll miss it if you blink.
Dude, I looked away. I looked at Mr.
Okay, so I'm going to take some. Orange rocks, okay? You guys see orange rocks, yes?
No.
Okay.
Is it gonna like fire?
Okay, so what was the color originally?
Orange.
Like a bright orange, okay? So now it's like tripled in size and it's green. So it's like making a little volcano, okay? So I'm going to take some of this volcano and we are going to make some fairies, but this is going to be Peter Pan rules for fairies, so you got to believe in them for them to stay alive, okay? So you got to believe in the fairies. Oh, you guys aren't believing hard enough. They're dying really quick. I don't think I got some. I got some. Those two fine. Oh, that one just died. Somebody really didn't believe in that one. Like, so all this started about 18 years ago when one of the things is that you'll learn chemists were lazy people, okay, and that the having to empty out a pumpkin, be able to carve it, put a candle in it, light the candle. Oh my God, I'm already exhausted from that. So I want everything just to be done all at once. So I'm going to take some magic rocks here. And we're going to have all the things happen all at once. Like, can you bring me the pieces back up as well? Okay, I'll try it one more time. Okay, so the rocks that I'm using are calcium carbide. So calcium carbide generates acetylene gas. So if I add just a little bit of water, you can see the gas coming up. That's acetylene gas that's being generated. And acetylene, flammable, it's the same thing like an acetylene torch. So if I add a lot of water to this, I can have a lot of acetylene gas. In here. Nice. Happy Halloween, everyone.